a less than 1, log x to the base a is greater than 0, and log x to the base a is less than 0 whenever x is greater than 1. Next we take up types of logarithms generally used. Generally, two bases, e and 10, are used in mathematics. The logarithm to the base e, where e is equal to, we know it, 1 plus 1 upon 1 factorial, plus 1 upon 2 factorial, plus 1 upon 3 factorial, plus so on, which accounts for 2.71828, are called natural logarithms. It is used in calculus and other branches where differentiation is being used. It has simplified the derivatives of logarithmic functions. Second, the logarithm to the base 10 are called common logarithms and was extensively used to solve huge calculation work. With the advent of calculators and computers, its use has considerably diminished. Here in this chapter, wherever base will be absent, it will be taken as 10. Thus, we work here with common logarithms unless mentioned otherwise. Note that in this case 10 is greater than 1, hence it is an increasing function. Also, log 10, when the base is not mentioned, it means log of 10 to the base 10, which is equal to 1. Log of 100 is equal to log of 10 square to the base 10, because base is not mentioned, therefore it will be taken as 10. That is 2 log 10 to the base 10, which is equal to 2. Similarly, log of 1000 can be written as log of 10 cube to the base 10, because base is not mentioned, therefore it will be taken as 10. 3 log 10 to the base 10 is equal to 3. Now log 10 is 1, log 100 is 2, log 1000 is 3. Now if we take up log of 0.1, that means log of 1 by 10 or 10 raised to power minus 1 to the base 10 can be written as log of 10 to the base 10 multiplied by minus 1. So log 10 to the base 10 is 1, that is minus 1. Therefore log of 10 raised to power minus 1 is equal to minus 1 in common logarithms. Also, log of 0.01 can be written as log of 10 raised to power minus 2 to the base 10, which can be equal to minus 2 log of 10 to the base 10 equal to minus 2. Note the following table. X, the values at 10 raised to power minus 3, 10 raised to power minus 2, 10 raised to power minus 1, 1, 10, 10 square, 10 cube. The values of log x are, at 10 raised to power minus 3 we have just now seen, its value is minus 3. At 10 raised to power minus 2, its value is minus 2. At 10 raised to power minus 1, its value is minus 1. At 1, log x is 0. At 10, log x is 1. At 10 square, log x is 2. At 10 cube, log x is 3. And in between them, it will be these values plus some fractional part, that is a fractional part which lies between 0 and 1. Thus, when it lies between 10 raised to the power minus 4 and 10 raised to the power minus 3, it will be minus 4 plus k, where k is the fractional part or decimal part, which will be later called as mantissa. Between minus 10 raised to the power minus 3 and 10 raised to the power minus 2, it will be minus 3 plus k. And between 10 raised to the power between 10 raised to the power minus 2 and 10 raised to the power minus 1, it will be minus 2 plus k. Similarly, between 10 raised to the power minus 1 and 1, it will be minus 1 plus k. Between 1 and 10, it will be of the form 0 plus k. This is called standard form. In modern teaching, this is taken as the core value, and thereafter all other calculations are solved from this because it is called standard form. And similarly, from 10 to 100, it will be of the form 1 plus k, where k is the fractional part. And 10 squared to 10 cubed, it will be 2 plus k. Now these integral parts of logarithms, they play a very, very important role, and we call it characteristics of the logarithm. So the integral part of a logarithm is called characteristics. Notice that we can always find the characteristic of a number from the above table. For example, the characteristics of log 32.58 is 1, as it lies between 10 and 100. Similarly, log of 10 will be equal to 1 and log of 100 will be equal to 2, and consequently log of 32.5 lies between 1 and 2. So 1 is its characteristics, and so on. Mantissa, the decimal part of the logarithm, is known as mantissa and is always positive and is obtained generally from the logarithm table.